Welcome, everybody. My name is Ram Ramanathan, and with me is Rajiv Salamat from PricewaterhouseCoopers. What we want to spend the next hour or so is talk to you guys about how you can use machine learning to kind of change common retail processes. Have you ever wondered how we can enable customers to find the relevant and the right product at the right time? Or how you can enable them to search easier than just doing a data textual query? Like, the people are more and more visual, how do we enable them to search better? And that's really what we wanted to spend some time over the next hour talking about, how we can apply ML for common scenarios in retail. Here is a lovely diagram of showing how we do a deep learning neural net. The rest of the session is going to be talking about convolution neural nets and spending a lot of time in deep learning. And the goal for it is, of course, to detect whether an image is a cat or a dog, which is great for my vision scenario, but what does that have to do with retail? The fact that you can find a cat or a dog is interesting. I love dogs, but doesn't really help you guys on a day-to-day basis. And that's really what we want to do, spend some time thinking about common ML scenarios that you can think of in your customers among your day-to-day use and how you can apply that. We think of three key scenarios where machine learning comes to play. One is enabling your customers or your users to find the right product at the right time. Right? How do we take people, moving them away from just regular textual searches to thinking about finding products more visually? The other aspect is, how do we help them recommend the right product at the right time? Right? If you really think about one of the things that we deal with more and more is choice, and the thing is, we can help customers is, how do you give them the right product at the right time based on their prior user behavior? And the third piece is, once you have released a product out into the wild, how is this product doing? What are people talking about it? What else are they referring to when they use this product? So you guys can get a better feeling of sentiment, understanding what they do with the product, and so that can then drive your life cycle from a product development perspective, marketing perspective, and multiple downstream activities. So I'm going to talk about a couple of three scenarios. So let's talk about why finding the favorite product. How do we do that today? Today, most retail stores, you normally think about their online web presence. It's normally you have a textual box, they do a product search query, and people normally kind of gravitate to search first. Part of it is because of their behavior that they do every day when they open up a Chrome browser and they search in the tab, and they kind of got indoctrinated to search first. So in those kind of scenarios, how is your search experience? And so far, searches have been mostly textual. But one of the things that we've seen more and more is people are moving more and more to images and video to kind of communicate, right? Whether it's in messaging applications, whether it's people pinning their favorite images on Pinterest or in their favorite social app, or even if you think about scanning through blogs, get inspiration to what they want to purchase. Once they do get the inspiration, what do they do with that? They can't really find their product at their favorite retailer anymore, right? Because it's an image, most probably. So how do we enable those scenarios? How do we enable your consumers to discover products easier? That's one aspect. The second piece is, how do we think about recommending the right product to the right customer? I think one of the use cases when we think about Google and recommendation is, we have over 1 billion hours of video content watched every day on YouTube. And you may say, OK, what's that got to do with recommendation? The reason people watch so much video on YouTube is because they see this related video tab on the lower right corner, where it's based on your user behavior, based on your product metadata, we then serve up appropriate videos that's relevant for your context. Not just to do clickbait, meaning that if you watch a cat video, show more cat videos, but really focus on what's relevant for that end user and thinking about time to view and saying, is this a video you really want to look at? That's the case of a content perspective, but you can then translate that to products on a day-to-day basis. Just because somebody bought something last year does not mean they're going to buy something this year, because there may be externalities like seasonality, there may be social events because one of the favorite teams won a sports event that may drive behavior. There may be other things that are more internal factors that drive recommendations, are out of stock, et cetera. And how do you think about taking all of that to drive the right product recommendation for your end customer? And the third piece is, I talked about, the sentiment, right? Really, now that you release a product, it's out in the wild, people are doing all kinds of craziness with your product, but then what's going on with the product? Do people actually like it, right? I mean, it's funny enough, like, I am a frequent customer of both Google Shopping and Amazon. I spend a lot of time reading those reviews, right? Those reviews clearly influence what I purchase, right? And so thinking about, for you as a manufacturer or retailer, you really need to understand what are people saying about this product out in the wild. And you really want to understand what else are they talking when they talk about this product. What are the other entities? Who's the most perceived substitute in the customer's mind? What else do they normally talk about from a competitor perspective when they talk about your product? How can we help you understand that? And that's normally all that data is not necessarily inside your organization. A lot of data is outside your organization and social media. How do you then harness all that data to get insights into your recommendation? So that's really what we're going to spend the rest of the time about these 3 scenarios: finding products, talking about recommendations, talking about sentiments, and how do we start driving scenarios. Here's a quick view of all the different services that we provide on Google Cloud Platform to really think about that. And what I want to spend some time is telling you how do we bring these services together for 1 or 2 scenarios. From a machine learning perspective, in general, there are 2 key ways that we provide access to machine learning. One is as a platform play, so that's really where we have clearly, we're going to be talking more about TensorFlow tomorrow, where we think about TensorFlow as a #1 open source machine learning platform where any of you can build your own models on your data, run it anywhere. And then when you're ready to run it at scale in a managed environment, you bring it to our cloud, and we have a cloud machine learning engine that helps you really drive your machine learning models, both from a training perspective or prediction perspective. And that's really targeted at data scientists and folks who want to really manage the machine learning lifecycle from end-to-end perspective. At the other end is really what we talk about machine learning APIs. So these are APIs that's really focused around using Google models, using Google infrastructure, and providing you targeted solutions for scenarios. For example, around language, we help you do things like finding named entities, meaning entities in a block of text, or finding things like sentiment. Whether it's an image, we released Vision API last year, so how do you find common entities? And in the case of video, which we just announced yesterday. So really, that's where we're using Google models to get insight into unstructured data. And we also have other APIs like Jobs API, where we focus on very targeted vertical use cases, like thinking about job placement. And that's really the kind of the portfolio of machine learning products that we have today from Google. Platform on one hand, based on TensorFlow with Cloud ML Engine, and a set of ready-to-use APIs on the ML API side. And the goal for this talk is talking about how can we use some of this technology to go back to those 3 scenarios I talked about. How do you find your products easier? How do you help drive recommendations? And the third aspect is how do you help customers understand sentiment? So let's first focus on the first one. How do you help find the right product? So there are a couple of things, and the scenario that I'm going to focus on is really around searches, search by image. As you can imagine, there are lots of other pieces that you can do from a find the right product. There are things around search engine optimization. There are things about how you can tune your existing search index and tuning whether you're using Elasticsearch. But those are, in my mind, those are technologies that have already been in the market for a few years. It's kind of a well-understood process of how you think about search engine optimization, how do you drive searches across your metadata today. People have solutions today. So what I want to spend some time thinking about is how do we think about finding the right product? And that there are a couple of things you can go around the thing. One is, how do I, when the user of your website sends an image as part of the search box, how can I get metadata on that image? What is that image about so I can drive a search process? The other aspect is thinking about logos. How do I drive, is there any product branding information that I can take to drive certain aspects? And then how do I think about fraud? If I'm a marketplace and different people are posting, sellers and buyers, sellers are posting products that they think they're ready to sell, how do you know as a marketplace owner that this is the right product or not? Is somebody just doing a phishing exercise where they're taking some random stock image, posting on the marketplace? Is this a valid image? And so we're just going to talk about a couple of ML techniques that enable that scenario. The first piece is image metadata. This is something we released last year. It normally works in scenarios it really works in more generalized scenarios. So the information you get back from what we call a Vision API is more generic, I would say higher level categorization information. It's not very targeted, specific information. But it can give you things like it's a leather handbag and give you the color of the handbag, and that can then drive, give you metadata to then drive a subsequent search. The other piece, so for example, one of our customers may have used, they may be enabling a search by image feature in their app. They want to start driving things like, hey, I want to search for, say, brown canvas bag. So we'll give you the color, we'll give you the term it's a bag, and potentially if it's a canvas bag, and then you can then drive a search index based on that within the metadata they've collected already. Another piece that we talked about is using, how do we think about using the web for fraud and topical entities. What that is if we just released our new feature called web detection. So that's really the functionality under Google image search. So what that gives you is, if an image exists on the web, right? So that's an important point. If an image exists on the web, and our web crawler, as you can imagine, we crawl through billions of pages on a daily basis. We index a lot of these images. We can then find metadata about that image and feed that back. So when you post an image to us, we can then tell you this metadata on this image based on lots of different pages that we scan, this means A, B, C. Does that make sense? And we can also tell you where this image, if a similar image exists somewhere else on the web. So that's another aspect that we provide. So really the scenario that we think about is if it's topical entities, where scenario, for example, you want to find a product with a very famous logo, we can pick up that a character, like a Marvel character or a character from a BBC show that's very popular in the web. We most probably will pick up that character from an image. And the other aspect is also for fraudulent scenarios, where if you're a marketplace, you want to see, are these people posting fraudulent images or stock images on my marketplace? Right, so we'll do that out of the box. And I'll show you some examples of that. But be careful about this, because we use the web metadata, we can get a lot of false positives too. So for an example of this is clearly a stormtrooper image, but we also give you a metadata called pregnancy. And you're like, why did you get that? So if you click on this link, it actually goes to a Pinterest page, and somebody there has used this image to drive a baby shower. Right? So that's because it's a very popular pin page, and so a lot of pages are linked to it, and that drives our ranking, and then clearly also on this image of a stormtrooper helmet is now linked to pregnancy. So you just need to think through, I just want to caution you, this is not a antidote to all problems. It works well for many scenarios, but also doesn't work well for some scenarios. So that's a piece that I want to leave you guys with. So let's kind of walk through how we want to do that. Can you switch to a demo? Perfect. So in the first thing, so let's start off with this. I'm a big Star Wars junkie, so in case you guys seen a lot of things, there's a reason for that. So it's not like Disney's endorsing me or anything like that. It's just that I like Star Wars stuff. So here's an example where, for example, we get all this information based on this image. Like it's a Lego, it's a Star Wars, it's a Lego Star Wars, so information about the product. And if you go back to the prior image where we talked about the and bag, so let me go back to that scenario. So here's another example where, in this case, it's a mug. Again, I'm a huge Star Wars junkie. So in case you're wondering why all my products all have some relation to Star Wars, it's just because Rogue One's an awesome movie. I think I'm not wired on the internet. Because I think you guys, sorry. Oh, yeah. Perfect, thank you. So let's go back and start this again. So for example, in the image that I just showed you earlier in the thing, so in this case, it brings up a letter bag, and we can give you, here's the metadata we give you, and this is the other additional metadata you get from the web. And so you can imagine how you can start using this metadata to drive the scenarios. Again, I just want to reiterate, for the web metadata, it really depends if a similar image exists on the web. So if it's an object that's not present on the external web, you most probably will not get any metadata on it. I talked a lot about products, but there are also other cases where people are thinking about furniture shopping, people are thinking about other scenarios, and here's a couple of examples of that. So in this case, I basically grabbed a bunch of images from, for example, you have potentially a furniture store. People are coming and loading images. They want to find similar stuff. And here you can imagine where we get metadata on those pieces. Out of the box, we give you additional metadata that you can now use to drive potential additional searches downstream. I'll do one more image, and then I'll go back to the rogue one. So the key aspect is here, for example, we recognize it's Rogue One Star Wars, it's Jyn Erso, et cetera, based on this cup. And this is a cup. And then the other piece that we also give you is information where else does this image exist. So you can imagine we give you this additional information of all the stores where this image shows up at. So that's another additional piece. If you think about a marketplace, people have uploaded a bunch of images. You guys want to do a quick fraud check to see if these images are stock images or they're coming from a valid place. You can very easily run those images through the API and see if these are valid images or not. And then use a subsequent metadata to drive searches. Back to slide. So let's move on to the next use case. We're talking about recommendation. So in the case of recommendation, there's a lot of different scenarios that we want to talk about. Really, you can think about it drives a lot of different scenarios, all the way from thinking about how you do the right content in YouTube to thinking about how you can drive the appropriate cross-sell or upsell for the customer. But as I mentioned, there's a lot of different factors that drive into the recommendation aspect. So you really want to think about what's the history of the user behavior, what has the user been doing on your site, or what purchases have they done with your store prior to that. What's the current product metadata? That's really where, if you can imagine, if your product is more of a physical device, your product is more of a soft device, whether it's a video, whether it's a piece of content, you really want to get that metadata so you can drive things downstream around recommendation models. And Rajiv is going to talk a little bit about some of the models that enable that. We provide you a rich platform to enable that. And so right now, what we use is TensorFlow. So then really, when you think about machine learning, there is a pipeline for that. There's a pipeline for really thinking about training. How do you think about training this a model where you take your data, the data can sit either in GCS, in Google Cloud Storage. You feed it through a data flow pipeline to process the data to get the right features that you want. Then you get a TensorFlow model that you have gone through training, that you look at the model parameters, tweak it appropriately, and then the model goes into production, which then drives downstream processes, right? So this is really where TensorFlow and things like Cloud ML Engine comes into play to really drive this end-to-end model scenario. But then you can imagine the pipeline doesn't just sit with machine learning. The pipeline is end-to-end. The pipeline goes with all the way from how you think about your logs data, your clickstream behavior coming in from whether it's Cloud Pub Sub, whether it's metadata flowing through things like cloud storage, and all the way, and the end result is really thinking about all your analysts who have to do things around, hey, help me understand my prior history, my sales behavior, my purchase history, and thinking about how to then figure out all the BI and data warehousing stuff that's been going on for 10, 15 years. All those things does not go away with machine learning. I think you can imagine you need that to drive machine learning. If you don't have that, you can have to go back and fix your BI and data warehouses. Because without data, there is no ML. Right? So the dirty secret of machine learning is 90% of the work is getting your data into your data warehouse, cleanse, process, so you can drive downstream machine learning processes. So we shouldn't forget that piece. Because think of it as a tip of the spear, right? It's a shiny part, but it's a lot of work that happens to get that data to the model for training. So this kind of scenario kind of talks to you about the end-to-end pipeline, not just from how do we feed data, think about clickstream behavior. These are lots of events that goes through across all your servers, feeding through a Cloud Pub Sub pipeline that's integrated with Dataflow that does the processing. It then dumps your data into BigQuery, where your analysts most probably are going to run a bunch of queries, analysis on that with your favorite BI tool, whether it's Tableau. And then once you've kind of done your data processing, what I call the data janitorial work, where you figure out what's the right data, what's the right features, you then do subsequent processing, feed that into a format that's compatible with TensorFlow, create your cloud machine learning model, create a TensorFlow model, and then you do some appropriate level of evaluation, then put it in production, most probably not directly in production. You will have to do things like an A/B test process. You figure out if this is the right model, am I getting the results I want in actual production before you roll it out. Right? There's a lot of processes that happen before a user behavior data goes to an actual ML model. What I wanted to hand it off to Rajiv is to talk about how someone actually did this in production. And Rajiv kind of is going to walk through a use case where he's helped the customer walk through the scenario end to end. Rajiv.
Thanks, Ron. I'm juggling lots of devices, and I hope all of them work OK with Wi-Fi and the screen resolution. Great. So I do machine learning stuff at PwC, and we do a lot of the dirty work that Ram was talking about, taking data, taking historic data. And we see across our clients, we see some clients who have a lot of data, but they have security issues about what can be used, what cannot be used. Some clients don't have data, and some clients just don't know what type of data they have. And we take that data and we figure out how to put it in the right context, and we've built several training models on TensorFlow. And I'll talk about one of them, which is for a company called Sky, which is a large television package provider in Mexico. It's kind of like the Verizon or AT&T of Mexico. So you can go to the slide. So the challenge here is that they literally have door-to-door salesmen who go and try to sell you different television packages. And over the years, they've got lots of sales data, but they lots of sales data in terms of what television package was sold to which area, but they don't have any data in knowing which type of people are interested in sports packages, which type of people are interested in HBO, who wants to watch reality TV, or anything like that. So what we created for them is we built simple tablet applications, retail kiosks, Sky retail kiosks for them. So users can interact with these kiosks in a fun way, and they can just pick a few movies or TV shows that they like. And based on that, the machine learning code figures out what type of television package and what kind of hardware along with that person would be best suited for. This is a problem where you have to try and figure out what a user wants with very little data. In other sessions, we've spoken about what to do with a lot of data. So, and we built this on cloud platform. Essentially, what we have is the kiosk screen, and there's all the app code is driven on App Engine. And we basically have the input data coming when a user selects different TV shows that he or she likes. And that goes into a single-layered neural network that we've built and deployed on TensorFlow. And I'll show you some screens and graphs from that as well. And based on that, the TensorFlow figures out what product should be recommended for that person. Essentially, the math challenge here is how do you do good filtering for a user without having a lot of data about that user? There's a lot of different types of filtering you can do. Essentially, I mean, they all have fancy names, but basically it comes down to, do you want to filter stuff based on what this user has done in the past, or based on if I like to watch HBO, somebody else likes to watch HBO, and that somebody else also likes to watch Comedy Central, then what's the likelihood I would like to watch Comedy Central as well? And there's different types of filtering techniques like that. We've picked a collaborative filtering technique here. What it basically means is if you have all your users on one axis and you have all your shows or TV packages on the other axis, you have some data for users for some of the packages, and you have holes in places. And so the whole mathematical challenge is how do you fill the holes? How do you know that if I've picked A, B, and C, then what's the likelihood I'd be interested in D as well? And the reason we use TensorFlow for this is our initial training data had something like 20,000 users. And on the other axis, we had some data for these users on about 300 different types of TV channels. So essentially, it was like a 20,000 by 300 matrix that we were executing. But that pretty soon exploded into having over 2 million users and something like 20,000 data points. And so that becomes a very hard computational problem. And that's where you can just, you can easily tweak your models in TensorFlow to scale with the amount of data that you get. So I'll try to show you some of these things. Do you know which one to plug into the tablet? Can I have the tablet screen, please? There you go. It's going to be a little psychedelic, because for some reason I can't get it to work in the other resolution. But think of this as your afternoon neck exercise. But you could also drop by at the PwC booth, and it works in a less psychedelic way there. So now let's tap on this. We call this the TV show gobbler. So it first has a little image recognition thing. It recognizes me, but I always make this joke that all machine learning, the goal is to detect Indian names properly, and it still detects Rajiv as Ratchet, but we'll go with that for now. Let's play. OK. So imagine this as a kiosk, and it shows you a bunch of TV shows, and you select a bunch of things that you like, and it's going to try to figure out what your interests are based on this. Definitely Halt and Catch Fire. Westworld. And if you see the bottom tab, it already detected from a very little amount of data, it detected what I like. Obviously, the more number of things that I pick, got to pick the wire, the more number of things that you pick, the more it learns about you. And so let's see what it kind of figured out about me. So it figures out a bunch of interest tags, a bunch of things based on facial recognition. It tries to estimate my age. And then it looks at, I've liked the show Halt and Catch Fire. How many other people have liked it? In that age demographic, how many people like it? And it executes that tensor computation. And I'll show you that. And based on that, it selects these different, the ones which are white are not things that are for me. And the ones that are in color are what the algorithm thinks I'd be interested in. And I'm so happy it didn't pick reality TV in front of all of you. So let's see what it recommends based on that. So based on this, now our customer, Sky, can figure out what type of bundle of TV package they can sell to me. And these bundles have different channels, and they're at a certain price. They have a certain amount of hardware with it. And if I select one of these bundles, and then you can have other related products to it. And this also has image recognition, where if I place a product in front of it, it'll detect the product. It's trying to do it right now, but I don't have a product to place in front of it. But any product, whether it's a bar code that it could have, or a product, you put a Google Home or a Daydreamer or something in front of it, it'll pick it up, it'll find the right price, it'll allow you to add it to your queue, contact the sales rep, all kinds of things like that. So if you come over to the PwC kiosk at some point, we'll show you all these things in a better screen resolution. If I can have the laptop again, please. Can I have the link for the TensorBoard? OK.
Could we move it to the demo box?
Great. So I'm not sure how many of you know a lot about this and are going to grill me about that. How many of you don't know much at all about TensorFlow? So I'll briefly go over some things. So essentially, TensorFlow is a computation engine, right? And you give it some model, and it's going to execute it for you. And how you design that model, which in this case happens to be a single-layer neural network, And when you feed it, so you see this thing called softmax here. So that's kind of the function that we use, and that decides kind of the bias and the weight. So if you think about all the users on one axis and all the interests on another axis, let's say hypothetically it's a 20,000 by 200 matrix, right? So that's, and out of that, that's my input tensor. And that has to give me an output that tells me for each of these 20,000 users, which one of the 10 television packages they can sell to me. So the 20,000 by 200 input training tensor should give me an output of 20,000 by 10, essentially. And that's what, and to do that, essentially you have to do some kind of, if you were to do it without something like TensorFlow, you'd sit and compute different permutations and combinations of the weights that you have to put into this and the bias that you have to put into this. So the beauty of TensorFlow is that it allows you to define a function and play with the bias and the weight in rapid time till you can get your model to a level where, your input model to a level where it looks like you're getting the right outputs from the training set. So when you do that, when you have that model, and then if you look at the distribution, it's essentially, over time, it has to kind of converge. So you know that the bias that you've given, or the weight that you've put into your weighted algorithm, it's kind of coming to a sort of a convergence, so you know how good or bad your training model is. And I'll show you one last thing, maybe. So if you're doing anything with TensorFlow, and you've always got somebody yelling at you saying, how do I know how good or bad this is? How do I know how accurate this is? And you kind of have to look at a loss curve over time to kind of say, hey, it has to go down a little bit over time, even if it doesn't go down this much. If it's not going down and that loss curve is not reducing, then the variance is too high, and you have to go back and kind of tweak your model some more. So I just wanted to show you a couple screens of, and TensorFlow makes it really easy to do those things on TensorBoard and execute the functions on TensorFlow instead of having to kind of go through lots of permutations of iterations for those input functions. So that's what we did with one of our clients, Kai, and I'll give it back to Ram.
So that was a quick aspect of, so again, going back to the story we were trying to talk about, help customers find the right product. Then second aspect is help, from your perspective, recommend the right and relevant product at the right time. And then the third piece that we want to talk about is a little bit about how do we go back to understanding product reception, right? How do we think about what's going on in the field? How is this product getting received? What are customers talking about it? How do we understand product reviews, et cetera? And that's really what I wanted to spend some time for the rest of the third scenario and talk a little bit about how we can, this is really focused on natural language understanding. That's really going to be a lot of the scenarios we're going to talk about, is that aspect. There's a lot of other pieces that goes into kind of getting product reception. This focus, that you can imagine aspects where you think about reference for your product. There are other pieces like if you start thinking about social media and you think about the images that flow through social media and you want to start associating, hey, how is my product logo perceived in social media? What are people doing normally with my product? That's another aspect that we can think about logo detection and image processing to enable those scenarios. But the other piece, which is I think a lot more, I would say, fundamental, is product reviews, right? You guys, there's product reviews galore. There are things that people are talking about on social media. What are people saying about my product? There are product reviews coming from magazines, from publishers. Find my product, tell me what's going on, tell me what's relevant for my product. What else are they talking about? And the other aspects is when you look at a review, things that you want to understand in a review is what are the entities they're covering in my review? Right? For example, when they talk about a product, what other product are they talking about? What other competitor are they talking about? What else do they associate my product with? That's really the thing I just talked about. For example, suggest phones. For example, if I'm selling a new model phone, what else do people normally think of when I talk about my phone? And the third part is what's the sentiment? Was it positive or negative? So you can then drive those pieces. Further downstream pieces you can imagine are things like, hey, what are the most positive entities of features? What are the most negative features, et cetera, to drive product reception? There are lots of other pieces that come into this. If you can imagine product telemetry, if you're a product, electronic product, it's a key aspect to drive future product planning. But in these pieces, what I'm going to be talking about really around how can we use language understanding to see what the external world is talking about you. So if you switch back to the demo, perfect. So the thing that I'm going to focus on is the Nexus 6P. So basically, I'm going to start off with Nexus 6P and say, here is a product review. I picked a site. It's on trusted reviews. And they're focused on little aspects of how this phone is received. And what I'm going to do with that is actually use that product review in the context of our natural language API. So a natural language API offers things like named entity recognition. It recognizes the most relevant entities in a block of text. So it finds things like around organization, it finds things like people, it finds things like consumer goods out of the box. And most common nouns today primarily where these entities are normally linked to a URL in Wikipedia. So you find if it's an entity that's in Wikipedia, most probably will pick it up from a natural language API. So let me go ahead and grab this piece of text. I hate doing a live demo sometimes because I actually copied it, but then mechanical problems. So let's do this. So let's go and analyze it. So one of the things that I wanted to show that is the first thing it picks up is if you look at this concept called salience. So the first thing is it's scanned this article and it's picked up this article is really about the Nexus 6P. Right? That's the first thing you really want to understand. Hey, you're going to get a lot of text coming into your organization. What is this article about? So that's the first thing it finds out about. The other thing you want to think about is things that's really focused. One of the key value points that Google really wanted to land was premium, right? That's really, we focus on Nexus 6P as a premium consumer mobile device. And again, the good thing is the article actually brought that up into the flow. The other aspects is we wanted to talk about is other pieces around design, salience, other pieces that are the other consumer goods that's normally referred to with Nexus 6P. In this case, for example, we pick up the fact that people also talk about Samsung Galaxy S7 in the same article. So you can imagine those are pretty substitutes from a customer perspective. We're thinking about how do we bring those two products together. Let me do another example. In this case, I brought up the Pixel C. So I'm going to go ahead and copy that piece of text here. So in this piece, again, the key pieces that you want to think about is that, so what do we want to understand? We want to understand what is this article about. Second thing we want to understand is what other organizations normally is referred to when we talk about this product. We bring up aspects like Samsung. We think about other products that goes with that. And then the other things that I want to also start thinking about is this about a tablet? We figure out it's a consumer good out of the box. You can imagine we start picking up salient entities out of this. So the piece that I also want to then drive is, the next piece I want to talk about is how do we think about the sentiment of this article. So I'm going to bring up an article about Google Home. Sorry. I know watching me copy text is not the most fun thing to do. So a couple of things. In this case, so what we've done is look at the sentiment analysis on the using a natural language API. So basically, natural language API, when you take a block of text, you run it through an NL API, you get two kind of scores on that. You get a document sentiment, and the two pieces you get is whether the score from -1 to +1, -1 being negative, +1 being positive, and then the magnitude of how positive that article was. So in this case, you would think this article is actually moderately pretty positive. And then it gives you things like document sentiment. It kind of walks you through how the article itself kind of flows. So as you guys start thinking about taking this block of text, if you think about product reviews coming in, you want to start scanning all these articles, start figuring out which article refers to my product. And two is, as you said, and then second thing you want to start thinking about is, are these articles positive or negative on my product? And the third part that I'm not covering today is you can also imagine that you want to start looking at which features are positive and which features are negative, and that's some part we're not going to cover. So in the end, what can you do with that? So you can imagine things like relationship graphs, right? So here, what we've done is we basically ran every Wikipedia article through our named entity recognition, and we basically started mapping a relationship graph based on which entities are common together in an article. So this line basically shows if there are a lot of articles where, for example, Nexus 6P and Motorola show up in the same article, it's a thicker line and it's a shorter line. And the case, for example, Nexus 6P and Sony, we're only in a few articles with the right level of things, a much longer line and it's a thinner line. So it's a kind of a very crude form of a relationship graph. So you can now thinking about how do all these products fit together, what's the relationship with the product. You can even imagine you can start adding sentiment to that line. Say, are these normally got strong sentiments, positive sentiments based on reviews? So you can get a better feel as you start looking at, from a product perspective, from a sales perspective, how the relationships drive certain behavior. Does that make sense? And of course, that's great from a product perspective, but what I want to end with is something that's more important, something from who is Tywin Lannister related to in Game of Thrones? Because I'm a big Game of Thrones fan, so you can imagine you can do something similar for Game of Thrones thing, and you can see right now that Tywin Lannister is connected to Tyrion Lannister, even though it should be a much stronger relationship, as you guys. How many of you are Game of Thrones fans? Not that many, so this joke just went right over your head. All right, so coming back, slides, please. So what we went through right now is, again, kind of circling back to what we talked about. We talked about the three key scenarios that machine learning can enable. One is, how do we find the right product, right? How do we provide a more intelligent search process within retail sites, thinking about image metadata primarily, in this case, is search by image. The second piece we talked about is recommendation, and Rajiv walked through a scenario about how do we enable customers to recommend the right, how do we enable sales folks to recommend the right product to customers. And the third part we just talked about is understanding feedback based on products and understanding how are people talking about your product, what else are they talking about, so you can start building relationship graphs with appropriate level of sentiment. So that's really what I wanted to cover in the session. I want to leave time for more questions for you guys for the next 10 minutes or so. There are lots of other sessions that cover going deep more into machine learning. Some of them may already be done. So when we did the slide, you can imagine a lot of sessions that happened before. I think there's one tomorrow around the data lifecycle, which I would highly recommend also. And there's things around how to use TensorFlow. With a lot of the things that Rajiv talked about, there's a good session around how do you do TensorFlow and CloudML without a PhD. I think those videos are up on YouTube. So those are sessions that if you guys are really more interested in TensorFlow, I would highly recommend. Some of the aspects around ML APIs, we have a session that covers basically how we do all the different ML APIs, kind of does a walkthrough that Sarah Robinson did earlier today. Those videos are also up on YouTube. So with that, Rajiv, I'd like to invite Rajiv up and open the door to questions.